Hello viewers. So in this problem we are given a 600 picofarad capacitor. So this is our 600 picofarad capacitor, and this capacitor is connected with a battery of 200 volts and its capacitance is 600 microfarad. So now the battery is going to pull off the negative electrons from this plate, making it as positive, and that electrons would be deposited on the other side of the capacitor plate, right? So in this scenario the battery is going to do some work, and that work done will be stored inside this capacitor in form of electrostatic potential energy. Initially there was zero charge on the capacitor. Now when we connect it with the battery, the capacitor starts charging until the potential difference between both the plates also reaches the battery voltage. After that the charging process will stop, and that would be the maximum charge on the capacitor. So that charge would be equal to C times V. So capacitance is equal to 600 into 10 raised to minus 12 multiplied by 200 volts. Since everything is in SI unit, our answer would be 6 2s are 12 into 10 raised to minus 8 coulombs. So this will be the positive charge on the positive plate, and that would be the negative charge on the negative plate. So negative plate would be having minus 12 into 10 raised to minus 8 coulomb. Positive plate would be having plus 12 into 10 raised to minus 8 coulomb. Now since the battery has done some work, so that work is stored inside the capacitor in form of electrostatic potential energy, which is given by half into C V square. So here if I substitute the value, that is equal to 600 into 10 raised to minus 12 multiplied by again 200 the whole square. So if you solve this, you will get your answer as 12 into 10 raised to minus 6 joules. That will be your answer, right? And it is not actually the final answer, it is the energy stored in the capacitor. Now the main problem starts from here, that if you have this charged capacitor which is already having 12 into 10 raised to minus 8 coulomb charge over here and same negative charge over here, and it is already having potential difference 200 volt across it, and it has got this much amount of energy stored in it. Now you are connecting that with a similar capacitor. Now that connection can never be series, because otherwise two terminals would be left over. If you could just connect it in the series over here, then the first part, this one, and the end part will remain disconnected. So you have to connect it in parallel only, like this. So if you are joining two things, it has to be always a parallel connection, right? So now this capacitor is again having same capacitance but uncharged. So what is going to happen? The charges, that means here it is 0 volt, no charge over here. So the charges will flow from high potential to low potential, and slowly and steadily the charge on this plate will start building up until both the potentials become equal. So the final situation will be something like this. Both the capacitors will attain same voltage, and that has to be of course 100 volt. The splitting would be the same, right? No matter whatever may be the capacitance, but the final voltage across both of them would be the same. So now both of them will have 100 voltage across them, and we do know their capacitances are same, 600 microfarad, and here again 600 microfarad. By using this analogy, you can even find the charge in both of them. Of course that will be half of the charge which we have already found out, right? So this is going to lose the charge and this is going to gain the charge. Finally the charges will also be equal. Now what am I going to do is, let me call this situation as situation A. This is situation A and this is situation B. Now in situation A already this was the amount of energy. Now I'm going to find out the total energy in both the capacitors in system B. So total energy is sum of both the energies. So simply I'm going to write down twice the half CV square, because capacitances and voltages are same. So twice into half into capacitance is 600 into 10 raised to minus 12 into voltage across both of them now is 100. So if I cancel this off, I'm going to get my answer as 6 into 10 raised to minus 6 joules. So guys, if you look carefully, earlier the capacitor was having this much amount of energy. Now if you combine them both, the total energy of both the capacitor is this. That means almost the same amount of energy is lost in form of heat, and that happens while the charging process, because in this process the above capacitor, this one behaves as a battery and it is going to donate its charge to this one. While the charging process is taking place, it is going to lose some amount of heat energy. So earlier the total energy was, so the heat energy or the energy lost can be written as the total energy before minus the total energy after the connection, right? And so this is 12 into 10 raised to minus 6 minus 6 into 10 raised to minus 6. So our answer is 6 into 10 raised to minus 6 joules. Now guys, you can just remember a short trick, that if one capacitor is fully charged and if it is connected to the identical capacitor, and that has to be always in parallel connection, then exactly half amount of energy is lost in terms of heat.